bag of words treats every word equally, but the word the appearing 50 times in a document tells you nothing useful, while the word fraud appearing 5 times in a banking document tells you a great deal. TF-IDF fixes this by weighting words based on how important they actually are. In this episode, we go line by line through the math and the implementation. TF-IDF stands for Term Frequency multiplied by Inverse Document Frequency. It assigns a numerical score to every word in every document. A high score means the word appears frequently in that document, but rarely across the rest of the dataset, making it a strong signal for that document's topic. A low score means the word is either rare in that document or appears so commonly across all documents that it carries no discriminating power. Term frequency measures how often a word appears in a single document relative to the total number of words in that document. The formula is the count of the word divided by the total word count. In this example, cat appears twice in a document of 8 words, giving a TF of 0.25. The word the appears 3 times, giving a TF of 0.375. TF alone is not enough because it still rewards common words like the. That is where inverse document frequency comes in. Inverse document frequency measures how rare a word is across all documents in the corpus. The formula is the logarithm of the total number of documents divided by the number of documents that contain the word. The logarithm dampens the effect of very large numbers. A word that appears in every single document gets an IDF close to 0, meaning it carries almost no discriminating value. The word the appears in all 3 documents, so its IDF is log of 3 over 3, which is log of 1, which equals 0. The word cat appears in only 2 of 3 documents, so its IDF is higher, reflecting that it is more informative. The final TF-IDF score is simply TF multiplied by IDF. A word with high term frequency and high inverse document frequency scores high, meaning it is both common in this document and rare across the dataset, making it a strong signal for this document's topic. A word with high term frequency but low inverse document frequency scores near 0. The word the has an IDF of 0, so its TF-IDF score is 0 regardless of how many times it appears. TF-IDF automatically suppresses common words without any manual stop word list. Scikit-learn provides TF Vectorizer, which handles all the TF-IDF calculations automatically. The interface is identical to Count Vectorizer. Create the vectorizer, call fit_transform on your corpus, and you get back a matrix of TF-IDF scores. Each row is a document and each column is a vocabulary word. The values are now TF-IDF scores rather than raw counts. Notice that the word the will have a score near 0 across all documents because it appears in every document and contributes nothing unique. Here is a practical example of TF-IDF feeding directly into a text classifier. We use scikit-learn's pipeline to chain TF-IDF, vectorization, and logistic regression together. The pipeline treats them as a single unit. When we call fit, it first transforms the text into TF-IDF vectors and then trains the classifier on those vectors. When we call predict on new text, it first vectorizes it using the same vocabulary and scores from training, then runs it through the classifier. This is the standard pattern for classical NLP classification tasks. TF-IDF is a significant improvement over raw bag of words, but it still shares the same fundamental limitations. Word order is ignored. There is no semantic understanding, so the words good and excellent are treated as completely unrelated. The vocabulary is fixed at training time and unknown words are dropped, and vectors remain very sparse for large vocabularies. These limitations motivated the development of word embeddings, which represent words as dense semantic vectors and capture meaning and relationships between words. We will cover those later in this series. You now understand TF-IDF from the math all the way to the implementation. Term frequency rewards words that appear often in a document. Inverse document frequency penalizes words that appear across every document. Together, they assign scores that reflect true word importance. In the next episode, we cover n-grams, a technique that brings back some of the word order that bag of words and TF-IDF throw away. If this helped you, subscribe so you do not miss the rest of the series.